The first thing to set up a secure miner is to configure the log server's config file inside the project. By default, the config file collected the metadata for 3 log servers running on localhost 8087, 8088, and 8089. The merge key field specifies the case attribute in which log servers store the process instance identifiers of their event logs. To run the secure miner, you can use the run miner shell script that deploys the trusted app inside the TEE. The seg size parameter specifies the maximum kilobyte size of the segments sent by log servers. The port parameter specifies the port of the secure miner. Finally, if your secure miner is not running on an Intel SGX enabled machine, set the simulation mode parameter to true. Now we can deploy the secure miner using our shell script. To run the log server, we are going to use the run log server shell script. The port parameter sets the port of the log server. The log parameter specifies the event log to provide. In the provision data folder of the project, we propose different event log samples. For now, let's use the one in the motivating folder. The merge key parameter specifies the name of the instance identifier attribute in the log to be provided. The measurement parameter specifies the expected measurement of the secure miner used during the remote attestation. Finally, the skip attestation parameter must be set to true if the secure miner is running in simulation mode. After setting this parameter, the log server is ready to be run. To showcase the capability of CONFINE, let's consider a setting with 3 provisioners collaborating in this process model. Let's see how to execute process discovery and conformance checking in this scenario using our CONFINE prototype. In the bottom right corner, we have a secure miner running in a TEE, while the rest of the terminals are associated with the 3 log servers of our example. Once the secure miner starts up, we need to copy its randomly generated TLS certificate in the miner list JSON file inside the provision data folder. The discovery algorithm offered by our prototype is the heuristic miner, which we implemented in incremental and non-incremental variants. Let's run the incremental variant by pressing the 1 button. If everything has gone right, the log servers will send their segmented event log and the secure miner will output the location of the computed process model outside the TEE. At the end of the process, we can expect the output PNML file with any visualization tool like WUBED and ensure that it is consistent with the interorganizational process model showed previously. To execute the conformance checking, we ported in our prototype the conformance declare algorithm from the PM4Py library in the Go language. Before running the algorithm, we need a JSON declarative process model in the input folder of the project. Now let's run the incremental variant of the conformance checking declare algorithm by pressing the 3 button and specifying the name of declare process model inside the input folder. Finally, the output of the conformance checking procedure can be found in the output folder of the project.